this out. This athlete is crossing a high slack line, and as she's moving, she's trying to keep her balance, and she does that by moving her arms and shifting her weight to reestablish balance. And this is exactly what happens to a chemical system at dynamic equilibrium. Let's talk about Le Chatelier's principle. And to do that, let's start with the definition. A system at dynamic equilibrium, so a reversible reaction, will minimize any changes to quickly reestablish a new equilibrium. So the goal is just to minimize the impact of any changes to the system. There are 3 types of changes we're going to look at. Changing concentration is pretty easy. It's straightforward. If I increase the concentration of my reactants, I'm going to then form more product to counteract that change. Vice versa, if I increase my concentration of product, you'd expect the reverse reaction to be favored. I'm creating more reactants to make up for that change. Let's move on to pressure. Pressure and volume are going to be inversely related. So if we have changes to pressure and we have gaseous reactants and products, we're going to expect to see shifts in that reaction. So for example, if I have increased pressure, it means I've reduced volume, I'm going to favor the side that has fewer moles or molecules of the gas. And to do that, we're just doing simple mole ratios. You're just looking at the balanced equation. So in this case, I have fewer moles of gas on the product side. So if I increase the pressure, that's the side I'm going to favor. If you have equal moles, pressure changes do not actually impact the system. And the last stressor we're going to talk about is changes in temperature. This is not as straightforward. It's going to be dependent on whether the reaction is endo or exothermic. And you're just going to think of heat as a product. So for example, this has a negative enthalpy. That's going to be an exothermic reaction. So if I increase the temperature, I have more heat. Therefore, I'm going to favor the reverse reaction. But wait, we didn't talk about catalyst. Well, that's because catalysts don't apply to Le Chatelier. If you use a catalyst, that's going to increase the rate of both the forward and the reverse reaction, but it's not going to change the equilibrium position. Follow Chem with Corinne for more straightforward content like this. Thanks for watching.